In high-performance engineering, whether you are designing next-gen EV battery packs, high RPM micromotors, or high-precision medical bobbins, insulation is never just a checkbox. It is a critical failure point. Every day, design engineers face a hidden enemy. Standard, off-the-shelf paper tubing often fails under intense thermal stress, absorbs moisture, causing catastrophic dielectric drops, or cracks under mechanical vibration. Today, we are diving deep into the material science of dielectric tubing and phenolic kraft paper tubes, and how choosing the right precision-engineered small paper tubes can save your design from expensive field failures. Let's talk about small cardboard and paper tubes. In low-spec consumer electronics, they work fine, but when you scale down to micromotors or medical coil bobbins, standard paper tubes reveal severe limitations. First, dimensional tolerance. Standard paper tubes deform easily due to ambient humidity. In a precision motor, a variance of just 50 microns can ruin automated mature winding or cause rotor friction. Second, radial crush strength. When high-speed winding machines apply immense tension using ultra-fine magnet wire, low-grade bobbins dish inward and collapse. You need a tube that maintains perfect circularity and strict tolerances under high mechanical stress. Now let's move into high-voltage environments, like EV batteries and power tools. This is where phenolic kraft paper tubes are traditionally deployed. Phenolic resin increases mechanical strength and heat resistance. However, not all phenolic tubes are created equal. Under prolonged thermal overload, low-quality phenolic materials undergo a process called carbonisation. The resin breaks down, and the surface transforms from an insulator into a carbon-conductive path. This triggers micro-arcing, short circuits, and eventually, thermal runaway. Add to that the risk of moisture absorption in humid environments, and your dielectric strength plummets. In the automotive sector, where space is tight and reliability is non-negotiable, standard tubes simply can survive the harsh environment or the corrosive nature of battery electrolytes. This is exactly why we re-engineered the manufacturing process for our line of dielectric tubing and phenolic kraft paper tubes. We specialize in precision small paper tubes, designed explicitly for demanding industrial applications. By cross-linking premium, high-purity kraft paper with high-grade, heat-stabilized phenolic resins, we've achieved a material that resists delamination and moisture intake. Our advanced curing and custom extrusion processes ensure a virtually zero dust output, preventing particle contamination in motor bearings. We control wall thickness and inner diameters to aerospace-grade tolerances, ensuring your automated assembly lines run flawlessly without jamming or tearing. Don't let a subcent component cause a multi-million-dollar product recall. Whether you need ultra-thin-walled dielectric sleeves for battery bolts, high-strength phenolic tubes for heavy-duty switchgears, or customized small paper bobbins for medical sensors, we have the material science to back your design. Click the link in the description below to visit our product page. You can review our full engineering datasheets, compare dielectric breakdown voltages, and request a free custom sample kit tailored to your exact specs today. Make sure to like, subscribe, and leave a comment if you are dealing with an insulation challenge right now. Our engineering team is ready to respond. Thanks for watching, and see you in the next breakdown.